Right. Question 4, first date September 2024, Physical Sciences, Paper 1, Grade 12. Okay, they are saying a 4.5 kg skateboard, a 4.5 kilograms, so that is the mass of skateboard, is pushed to the left at a constant speed of 3 meters per second. Right, so that the direction is to the left, and then the initial speed, that is 3 meters per second, on a horizontal flat surface. And they are now saying a boy of mass 45 kilograms runs to the right. To the right is the direction of the boy, and then the mass of the boy is 45 kilograms at a speed of 1.5 meters per second. So that is the initial velocity of the boy. And then after that, the boy jumps onto the skateboard. Right. So immediately when now the boy jumps on the skateboard, it simply means that the final velocity of the boy and the final velocity of the skateboard are equal, right? So the velocities are equal after. Now, 4.1 for 2 marks, it says state the law of conservation of linear momentum. State the law of conservation of linear momentum. That is very simple, and it's very important again to know the law of conservation of linear momentum. It says that the total linear momentum in an isolated system remains conserved. The total linear momentum in an isolated system remains conserved, or you can say it remains constant. All right. And then 4.2 is saying calculate the velocity of the boy and the skateboard. Right. So we are looking for the combination. Calculate the velocity of the boy and the skateboard immediately after he lands on the skateboard. So just like I said, immediately when he lands on the skateboard, it simply means that the velocities are now equal. The velocity of the boy and also the velocity of the skateboard, because we treat them as single item. All right. So when they are now saying immediately after, okay, it simply tells us that we need to calculate final velocity of both the boy and also the skateboard. So what are we going to use? We are going to use the principle of linear momentum, which says that the sum of momentum before is equals to the sum of momentum after, right? And we know that momentum is the product, right? The product of the mass and the object's velocity. So I will simply say the mass of A is for boy, right? Mass A, initial velocity of A, that is for boy. And then for the skateboard, I'll just say B, right? So that is the mass of skateboard, initial velocity of skateboard. Remember, after the velocities are now the same, right? Because now the boy lands on the skateboard. So we will just say mass of the boy plus mass of the skateboard, then multiply by the final velocity. So that is Vf there, multiply by Vf. Alright, then we can therefore substitute. What is the mass of the boy? The boy, I think they said 45. Yes, 45. And make sure that the units are correct, right? Kilograms. So it simply means that we are correct. Everything is right instead. So 45, right? And then the initial velocity of the boy. And remember to choose the direction, because these two are in opposite direction. So left as negative, right as positive. Right, so the speed 1,5, that is positive. So this is positive 1,5 plus mass of the skateboard, that is 4,5. 4,5. So it's 4,5 multiplied by the initial velocity. Remember, we chose left as negative. So the skateboard is heading to the left. So left as negative 3, we will substitute it as negative 3. Right, so it's negative 3 is equals to mass of the boy 45 plus mass of the skateboard 4,5 multiplied by what? Multiplied by the final velocity. Therefore we can do our calculations. So 45 multiplied by 1,5 multiplied by 1,5 plus 4,5 multiplied by -3. This is going to give us 54, which is equals to, then add what is inside the brackets, that is 45 plus 4,9, which is 49,5, right? It's 49,5 VF. Then we can therefore divide by 49,5 on both sides in order to find the magnitude or the value of final velocity. So it's 54 divided by 49,5. This is giving us VF is equals to 1,09 meters per second. We found a positive answer. Remember, we chose positive, right as positive. We chose right as positive. So you can therefore write to the right.